Hello, this is Professor Grant Thrall. This series of videos is on Ceteris Paribus, all other things being equal, and that includes holding geography constant. So what do we mean by holding geography constant? In my field of economics, we say Ceteris Paribus, all other things being equal. We're making an assumption, and then we hold all phenomena constant, and we allow then one to change, and then see what the impact is on the entire system. In geography, we have a similar problem, where the data is packaged in what we might call a geographic container. That container is often a 5-digit zip code. It could be a census tract or census block or census block group, even a county or even a state. These are polygons to which data is assigned. But the problem with these data containers is that they are not uniform in size. They're not uniform in shape. They are irregular polygons. The result is that my mental map, my business decisioning might in fact be modified, might be changed just because of the geographic container. So we don't want to have a bias toward, let's say, a zip code that is really large in a rural area of a county, or a county like San Bernardino in California, which is really huge and has a significant population. But when you were to look at that geographic container and represent the population, it will attract your eyes to that being a very significantly large market, whereas in fact the market might be biased to be clustered closer to the Los Angeles metropolitan area than it is out toward the Colorado River. So how do I hold geography constant? How do I create my own data containers? And then once we have done that, let's have an example of how this is actually done and how that can influence our business decision-making ability. Here's an example of geographic containers for Memphis, Tennessee. And each one of these containers that you see on the map here is a census tract. And the census tracts are highlighted according to Esri's tapestry life mode groups. And indeed, it is a tapestry. But the census tracts are different size. So where the population density is great, the census tracts are small. And where the population density is low and there's comparatively few people per square mile, the census tracts are quite large, as you would see around the urban perimeter. Well, can zooming in fix that? Here we are zooming in to the core of the city of Memphis. The census tracts are comparatively similar size, but here the problem is that they're not the same shape. So we want to have size and shape held constant for our geographic container, and Geographic Information System allows us to do that. Here's another example, life mode. This is one life mode group, L1s, and you can look at the definition of a life mode lifestyle segmentation profile according to Esri's tapestry segmentation system, and we see, geez, there's a lot of L1s out here in the perimeter areas of the city. But that bias that's a mental bias. So I recommend to you the book Mark Molinaire, How to Lie with Maps. Really a great book and very easy to read book. From Amazon.com, they have this quote, which is where I copied and pasted it from. Mark reveals how and why maps can lie. He explains the methods, which might be deliberate or might be accidental if you're not careful, where you can represent information in a manner that may be incorrectly interpreted. So you can read the rest of this on Amazon or wherever else you buy your books. This is what I would rather like. This is what I would like to see. This happens to be the same data that we saw in the previous map of census tracts, but I've converted that into 3 by 3 mile grids. So this is the absolute count of L1 category households by 3 by 3 mile grids. It's a very different look than what we saw previously in that census tract map. Here's another example of using grids. This happens to be a 6 by 6 square mile grid for the entire state of Florida. So you say, well, Florida's population was growing at the height of the recent economy of 550 persons net per day. Some people left, some people came in from other states, leaving a net of 550. Well, they weren't going to the entire state. They were going to place specific. So if we're making a decision, let's say to locate a retailer to take advantage of some of that increasing population, it's not good enough to say, well, Florida. We might begin with thinking about Florida, but where within Florida? And there's places where the population is increasing and places where the population isn't changing at all. And immediately then our eyes are attracted to those areas where then we should hone in on and perhaps consider that as a location for our new retail activity. Now we're back to Memphis, and this is a count of life mode 1s and 2s from Esri on the 3 by 3 mile grid. And this is a percent of the population. We're back to the census tract, so it looks like L1s, L2s, and L3s are certainly all over the place. But this is what it looks like when we convert it to a 3 by 3 mile grid. It's a better representation.